for arithmetic fractions. So, arithmetic. No, arithmetic. Okay, how do we multiply fractions? We multiply numerator times the numerator, if you forgot, and we multiply the denominator times the denominator. So, for instance, if I want to multiply 1/2 times 3/7, I do 1 times 3. Of course, we wouldn't actually write the step out. 2 times 7 on the bottom, and we would get 3/14, and we wouldn't get a bracket around it, but that's okay. So, with letters, A over B times C over D is AC over BD. Yes? What do we do for division? We reciprocate the divisor, the second fraction, and multiply as above. I use the term kiss and flip. Why kiss and flip? Because a kiss is an X, and you flip the second fraction. Kiss and flip. So for instance, if I want to take 1/2 and divide by 3/7, I need to change this into a kiss and flip. So 1/2 stays the same, and we flip the 3/7 as 7/3, and we multiply. 1 times 7 is, and 2 times 3 is, so we get 7 over 6. Does everybody remember how to multiply and divide fractions? And in your opinion, would multiplying and dividing be easier or harder than adding and subtracting fractions? It's definitely easier. Yes, yes it is. Okay. Be sure to factor both the numerator and denominator, then simplify the fraction before. So I'll give you an example back in the day. If you have 5, 6, and I'm timesing it by, I don't know, like something like 12/13, you should try to simplify before you multiply, otherwise you get big numbers. So, for instance, 12 over 6, you can simplify to be what? 2 over 1, and you get 10 over 13 as a result, instead of getting big numbers that you have to reduce at the end. You should always try to simplify before you actually do the multiply or divide. Okay? Are we okay there? So, non-permissible values should always be stated. This is a given. I'm not going to say, like the quiz was today, you need to state the non-permissibles. You automatically have to state it. If a variable is in the denominator at any point, there's a non-permissible. Remember that. And remember that when you're dividing, there is a denominator before you flip it. So there's going to be additional non-permissibles. Okay, multiplying. Can anybody see the cross cancel here? 12 and 4. So what would I reduce 4/12 to be? A 1 and a 3, 1/3, right? And so what about the negative 5n squared times negative 15? Does everybody see negative 5 and negative 15 can cross cancel? And what would I get? 1 and 3. And then I have an n squared and an n to the power 5. What would that cancel to be? Oh, we forgot yesterday's lesson. There's more on the bottom than the top, right? So 2 of these n's will cancel, 2 of these n's here, and how many am I left with? n3. So what's my final answer? 1 over 9n cubed. I didn't even follow my directions here. Option 1, multiply, then reduce. So I'm going to, this one says reduce, then multiply. So I'm going to cross, we're going to just do a switcheroo here. Now we're going to multiply, then reduce. So what do we do here? We get top times top is negative 20n squared over, oh my, 12 times 15. I might have to pull out my calculator, but you don't get a calculator on this unit, so what would you do? Well, huh? You know the quick way of multiplying by 15 is 10 times something and then take half of it and add to it. So 10. Now listen. Does everybody understand? 15 is 10 and a 5 added together, right? So if I take 10 and multiply it by 112, I get 120. And what's half of 120? 60. That's the 5 part. And then you add it together, 180, right? Okay, now we have to actually reduce it. So what's a negative 20 divided by a negative 180? A positive what? Well, here's another little trick if you haven't seen it. If you have a 0 on top and a 0 on the bottom, do you know you can cancel that? Oh, I hope you got shown that somewhere. And then 2 18s can reduce to 1/9. And then the n, this is back in grade 9, you learned this, maybe grade 10 with negative exponents. When you have the same base, you subtract, right? So 2 subtract 5 is negative 3, but you don't leave a negative 3. You put it at the bottom, negative 3. The other way you can look at this, and this is what I did yesterday, I showed n times n over n times n times n times n times n. And you can see visually 2 of these n's will cancel. I'm left with 3 n's at the bottom, right? Okay. Divide. Oh, by the way, before I forget, because you shouldn't forget this, what's the non-permissibles? Not equal 0. Why is it 0? Yeah, because first off, there's only one variable, is n, and it's n, it's what times this will give you a 0 at the bottom, right? Okay. So, moving on. B. What do we have to do with divide? Oh, what do we do with the divide? We have to kiss and flip. So 3 over x times, I'm not going to use an x this time, x squared over 12. So this time I'm going to multiply first, then reduce, just to show you it's more work. So 3 times x squared is 3x squared. X times 12 is 12x. Then I'm going to reduce it. Does everybody see? The 3 12s reduces to? Yeah, 1/4, so I'm not going to put a 1. And then x squared over x, we'll have an x on top, right? Okay. Oh, I don't have it twice, so let's do it twice anyways. It would have been much easier if at this point 3 over x times x squared over 12, if we do the cross cancel, right? 3, 12, 4, 1, yes? The cross canceling. 3 12ths reduced to 1/4. Gotcha. Okay, and then the x squared over x, one of these x's, we'll cancel one of these x's. So does everybody say I get the same answer? X over 4. What's my non-permissible value? X cannot equal 0. From there, and even from there, that one doesn't get flipped, right? Because a lot of people will see it gets flipped here, so the x is no longer on the bottom. You have to look at the original question. Okay, do you guys want to try C? Stop. Thank you. Okay, so we got a kiss and flip. So 21xy over 4t squared times, I'm not going to do a, that's a t. Why would they throw a t in there? That's crazy, eh? So times 12 over 7x squared y. So does everybody see the 12 fourths will cancel and you get 3 1? What else can cancel? 21 7, so 3 1. What else? 1x will cancel 1x and a y and a y. So what are we left with? On top, 9. On bottom, t squared x.
I did that correct.
Okay, what's the non-permissibles? T cannot equal 0. Anything else? So t's on the bottom in the original, but what about after I flip? X and y cannot equal. So t, x, and y cannot equal 0. Anywhere in the bottom. Now, just to clarify why that works the way it is, does everybody see right here at this point? If x was 0, you'd get 0, this fraction would be 0 over something, which is just 0. But do you see then the original question would be something divided by 0? You don't see it? You can't divide by 0, right? T cannot equal 0 either. Okay, moving on. Yes, Gabe? Yep. Okay, so what do we do here? We flip it. 4a squared b squared c divided by negative 3ab times. Now, when I flip 6c squared, what does it become? 1 over 6c squared. Very good. So then what do? We can cross cancel. Can anybody see a cross cancel? 4 and the 6, what becomes? 2/3. Yes. And what else? A c. One c can cancel one c. Can you see anything else? On top of each other. Look at that. The a's can cancel. Remember? On top or across you can cancel. So one of these a's can cancel one of those a's. One of those b's can cancel one of those b's. And what am I left with? 2ab over negative 9c. Now you technically, because this is a monomial, you can place the negative wherever you want. You can put it on the top, you can put it on the bottom, or you can put it beside the fraction line. It doesn't matter. Now we still need to say my non-permissibles. NPV, A, B, and C cannot equal 0. Does everybody see that? At some spot in here, they are A, B, and C are all denominators, right? So just to test it, sub in 0 for A. Sub in 0 for A. Do you see you get a 0 at the bottom here? Sub in 0 for B. Do you get a 0 at the bottom somewhere? Yeah, right here. Sub in 0 for C. Can you divide by 0? No. Okay, next up. Next up. Can anybody see some cancellations? Yes. Y plus 1 and y plus 1 can cancel because they're both binomials exactly the same. Anything else we can cancel? The 5 and the 10. The 5 and the 10 is just a 5/10 fraction, right? So 1, 2. So what's my final answer? Over 2. And what is y cannot equal? So you put a comma here. Negative 1. Right here. Set it equal to 0 and solve. Y plus 1 equals 0. So then I hear plus 2. Can we have 2 as if we plug in 2 to the original, will we get a 0 as a denominator? No, 2 is okay. 2 is legit. Okay. Okay. Let's rewrite as multiplication. So x squared minus 4 over x plus 3 times 3x plus 9 over 4x minus 8. Who wants to cancel something right now? Okay, so what do you want to do here? We can't do anything, so we're done? You should always simplify before you multiply. So, how do you factor x squared minus 4? Yes, you do. It's a difference of 2 perfect squares. X minus 2 times x plus 2. Obviously, you can't factor x plus 3, so it's just going to stay like that. Can you factor 3x plus 9? Yes, you can. You can take a common factor out. A 3. Then you're left with Can you factor something out of the 4x minus 8? Yes, a common factor of 4. What are you left with? X minus 2. Now can you see some canceling that aren't going to involve any puppies? What can you cancel here? X minus 2 with an X minus 2. Why can I do that? Because they're both exactly binomials the same. What about this? You cannot do the 3 with the 3. This 3 is a monomial. This 3 is part of a binomial. It has to be a binomial with a binomial. Do you see it now? Okay, what's my final answer? How about there's a 3 times an x plus 2. 3x plus 2 over 4. And you might argue you could multiply that in. What is x not equal? So you go comma, x cannot equal. No, it's not negative 2. Negative 3 is 1. What's the other one? A 2. Again, the only thing we care about is denominators. Denominators. And there was a denominator over here, right here. Well, that ends up being that right here. Do you see that? Yeah. But we already took care of the 3 minus 3 from that, so it's all good. Okay. Whew, I'm exhausted here. This is a multiply, so I don't have to flip and kiss. So let's just go directly into factoring. So what do we get? What can we factor out of this top here? 2. Then we get m squared minus 4 over. What can we factor in the bottom? A 3. What are we left with? M plus 2. What can we factor in the top here? Oh, yeah, sorry. Oops. I got excited there. 2m plus 1. There we go. Good catch. Next one on the top. A 9, and we're left with m plus 2. No! 2m plus 1. Very good. Over. What do we get in the bottom we can take out? A 6. And we can take out a... Sorry, we took out a 6 and we get m minus 2. Is there any... Yes? Is there any more factoring I can do? Yes, right here. Does everybody see that's a difference of 2 perfect squares? So I'm going to do my next step. 2, m minus 2, m plus 2 over 3 2m plus 1 times 9 2m plus 1 over 6m minus 2. Okay, so can we do some canceling now? Yes. What and what? M minus 2 and an m minus 2. What else? 2m plus 1 and a 2m plus 1. Anything else? 9 and 3. Monomial, monomial. So 9 over 3 cancels to be 3 over 1. Yes? And what else? 2 and a 6. 2 and the 6. 1/3, right? 1/3. Oh, look at that. Look at that. Do we have something else? 3 and 3. Bam, bam. 3 over 3 is 1. 3 over 3. So what are we left with here, boys and girls? M plus 2. That's it. Look at that. M cannot equal what and what? M cannot equal what and what? Try again, not 1/2. Negative 1/2 and plus 2. What about negative 2? What about negative 2? What about negative 2? No, I tried to trick you. Okay. X plus 3, x plus 2 over x minus 5x minus 1 times, if I flip this in my head and factor, can you handle that?
Yeah.
So now I'm going to put this at the bottom. So this would be x plus, it looks like 6 and 3, hey? X plus 3. And then the x squared plus x minus 30. Okay, so then I can do some canceling. A lot of people were wondering if that's a bad thing, but that's a good thing. You can cancel, right? They're exactly the same. Cancel, 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 cancel. What am I left with? X cannot equal what? 1. 5. Minus 6, minus 3. Very good. Okay, finished F. Is everybody working on F here or what? There's a GCF in F. What's that? An X. So we're left with X plus 3Y. The bottom, in order to get 42, you need something that's 1 away from each other. That would be 6 and 7, so make it work. So that's going to be an X and a 6Y and an X and a 7Y, and you need a minus and a plus. Does everybody see how I factored that one? Kind of. I kind of just made it work. I knew if I forgot about the Y's and I just tried to factor x squared minus x minus 42, it's much easier, and then stick the Y's back in to make it work. Okay, so now we're timesing. Again, the same thing. If this was x squared minus 10x plus 21, to get a 10, I need a 7 and a 3 in order to get a minus. So x minus 3y, x minus 7y, yes? And then on the bottom, I have a difference of 2 perfect squares. You have to be really good at spotting those things. What's the square root of x squared? X. What's the square root of 9y squared? 3y. One's a plus, one's a minus. Yes? So then I'm going to take my red pen and start canceling. Cancel. 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 Did everybody cancel? Oh, can I cancel this x with this x plus 6y?
Don't you want us to fail?
Very good. Very good. So x over x plus 6y. Just so you know, this is going to be harder to find our restricted values here. So, okay, so in order to find the restricted values, I'm going to do this. I'm going to show all my steps because I know this is going to be complicated. So this can't equal 0. So set it equal to 0 and solve. X plus 6y equals 0. Set it equal to 0 and solve, right? So you move the 6y over, you get x equals negative 6y. So that means x cannot equal negative 6y. Okay, over here, x minus 7y equals 0. So what can x not equal? 7y. Yes? And this one, I'll do up here. X minus 3y equals 0. So x equals 3y. So it can't equal 3y plus or minus 3y. So that's how you do those when they have 2 variables, right? Okay, moving on. Compound fractions often have fractional expressions in both the numerator and denominator. To simplify, rewrite the compound fraction as a division question. Does everybody understand that this horizontal line here really just means division? So when we have a fraction divided by another fraction, it's just like the previous questions. It just looks really complicated, especially when it's in B form, when it has a line and a line and a line like that. In grade 12, when we do trig identities, you get lost with these lines, and a lot of times I'll just make this like a lot thicker so you can tell that that's the division line. Seriously. Okay, so you guys want to try this? Let's do the first one together. So the first step is to rewrite it as a division sign. So you have 3n plus 6 over 2n plus 2 divided by n plus 2 over n squared minus 1. Does everybody see that's the exact same question? I just wrote a division sign instead of this. This became a division sign. That's all that happened, right? Now I'm going to kiss and flip. Yes? 3n plus 6 over 2n plus 2 times n squared minus 1 over n plus 1. Sorry, n plus 2. Very good. Now we're going to do what? Factor. So what can be factored at the top here? 3, and we're left with n plus 2. On the bottom, 2. We're left with n plus 1 times, what's the top be factored to? N plus 1, n minus 1, difference of squares. And n plus 2 is just n plus 2. Can you see some cancellations? Yes? So n plus 2 and an n plus 2 and an n plus 1 and an n plus 1. So what are we left with? 3 bracket n minus 1 over 2. N cannot equal negative 1, negative 2. Anything else? Yes? Does everybody see there was a denominator right here? That denominator, sorry, this should have been still. What the heck did I do there? I already did, so that was a times, but over here, this was a denominator, right, to originally? So that means anything right here is free game for being a 0. And that means you can't have a plus or minus 1. Okay, and just to prove to you, again, because people aren't believing me the whole thing about this is a numerator, you said no numerator, but it was a denominator to begin with. So watch, if I put 1 in, positive 1 in here, what do I get? I get 0 right here, and you can't take, even if you put 1 here, you get 3 divided by 0. Can't happen. So the question can't even proceed because you have an undefined expression to begin with, right? Okay, so you got to watch for the division. There's an additional non-permissible value. Okay, do you guys want to do the rest? Okay, go, do it. So 2d plus 6 over d plus 1 divided by d plus 3 over d squared minus 1. So now I'm going to kiss and flip. At the same time on a factor, is anybody at that point where you can factor at the same time? It saves a step, yes? Yeah. So times, this is going to be factored. This is a difference of squares, right? So d minus 1, d plus 1 over d plus 3. Cancel, 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 cancel. You're left with 2d plus 1. Minus 1, sorry. And d cannot equal what? Plus or minus 1 and negative 3. Good job on the plus or minus 1. Okay, the next one. This is the divide sign, just so you know here, right? So this is 2b plus 1 over b minus 2 divided by b plus 1 over b minus 2. So this is 2b plus 1 over b minus 2 times b minus 2 over b plus 1. Cancel, 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 cancel. I am left with 2. B cannot equal 2 or negative 1? So my question to you is, I got an answer of 2 and b cannot equal 2. Is that okay? I hear no solution. Was I solving something? No. So this is good. It just simplifies to be 2. I didn't say b equals 2. I just said everything simplifies to 2. Right?